In this lecture, we're going to zoom in on overloading, overriding, and hiding. We have seen that overriding is a mechanism we have in C++ to be able to set up most specific versions of our virtual methods in derived classes. So for example, the draw method we have in oval is overriding or eclipsing the one we have in shape, and the draw method in circle is overriding or hiding or eclipsing the one we have in oval. This is the concept here. But what happens if we introduce the concept of overloading and mix that up with overriding as we have seen so far? So suppose we do something like this. This is our shape class. It is going to have two versions of the draw method. We have one that takes one parameter. For example, this could be the color that we want to draw our shape with. And another one is not going to take any parameter. And these are two overloads of our virtual method here. So what is going to happen in our derived classes that are going to inherit this virtual method? So let's look at an example. Here we have a simple example that is setting up objects of our shapes. We have a shape object, we have an oval object, and we have a circle object here. If we call the draw method on our most derived class, which is circle, we're going to see that this is going to work. We can draw without a parameter, and we can draw with one parameter, which is going to be our color depth. This is going to work just fine. We will be reusing our inherited method from the shape class, and this is really cool. But what happens if you override this method in our oval class? Suppose we hijack the inheriting process and set up another draw method in our oval class, and we only override the overload that doesn't take any parameter. We can do something like this. But the moment you do this, this is going to only override this method, and it is going to hide all the other draw methods that we had in our base class, which is shape here. And this is something I want you to know. So once you override a single overload of your virtual functions, all the other overloads are going to be hidden, and they won't be usable anymore by downstream inheriting classes. If you want all the overloads to be available to downstream inheriting classes, you have no choice but to explicitly override each of them, and that's how it's going to work. So if we look at the example here, we're going to see that the draw call without a parameter is going to work because this is overridden in our oval class. But if we call the one which takes a parameter, this is going to be hidden at the oval level, and we won't have access to that in circle. And if we try to call this, we're going to get a compiler error. Again, the message is, if you override one overload of your virtual functions in the base class, all the other ones are going to be hidden, and you have no choice but to explicitly override them for them to be available and usable in downstream classes. This is the message I want to convey here. Okay, so now we know this, but what if we set up another overload downstream? For example, what if we go in our oval class and set up another overload, which is going to have two parameters? For example, we might have the color depth and the color here that we want to draw with. Okay, so one thing you should know is that this method is not going to participate in shape polymorphism. And what I mean is that if we go through a base pointer or reference to manage derived objects, we can't really call this method with shape polymorphism. So if we go through our shape pointer or reference, we want to be really able to call this method. If we try to call it, we will get a compiler error. The reason is this method is not known to the shape class. That's why it's not going to participate in shape polymorphism. The only methods that are going to participate in shape polymorphism are the methods that are declared in the base class, and they are virtual. This is the condition here. And if you violate this condition in any way, shape polymorphism or base class polymorphism in this case is not going to work, and you will get a compiler error. So if you try to do something like this and you want to call your draw method with two parameters, you're going to get a bunch of compiler errors, and this is not going to work. Another thing I want you to see is that if you assign a derived object to a base object, your derived virtual functions are going to be wiped out as part of the slicing that we have learned about already. So the circle part is going to be wiped out, the oval part is going to be sliced off, and the draw method is going to go with our oval part, and we will only be left with the shape part. And if we try to call this method here, we will get a compiler error because it's no longer available, it's been sliced off. This is really what I want you to see here. Now that we know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is overloading, overriding, and hiding. We want to explore these concepts in a little more detail. We're going to grab the code from the last lecture because that's going to be a good starting point. We're going to take out the binary. We don't want that, and we're going to copy. And we're going to put that in our current project here. This is going to do. And we are going to open this in Visual Studio Code pretty quick by dragging and dropping here. And we're going to see that we have a bunch of virtual functions here. We just have the draw version, but we can set up an overload of this draw method here. This is what we want to do. So I am going to go below here and set up an overload of this method. This is going to be taking the color depth as a parameter, and we want to see how usable this is downstream. So we're going to go down in the main CPP function and take out what we don't need here. We really need a bunch of objects. We can set up circle 1 and oval 1, and we will see that we can call these methods. We're going to say circle 1 draw without a parameter, and we're going to say circle 1 draw and pass in 44 as our parameter. And let's go back and make sure that we have our overload n. This is going to be taking the color depth. And let's try and build our program because we have a squiggly line here. Let's see if it is just Visual Studio Code playing games with us. We're going to pass this through GCC, and we will have a compiler error here. So what is going on? Candidate virtual draw const. Let's go up and see what kind of problem we have here. This is the concept we just talked about in the slides. We are setting up our overloads here, but this is being eclipsed by the overloads that we are setting up in oval. You see we have a draw override, and this is also being eclipsed by the override we have in our circle class here. If we want the two overloads we have from shape to be available, we can comment out the overrides we have both in circle and oval. Let's do that. And that's going to be available and usable. So let's do that. This is a really good learning opportunity. And now if we go in main CPP, we're going to see that this is going to become available. So we can build this with GCC again to bring Visual Studio Code up to date. And you see the build is good and our methods are usable even from derived classes. So for example, we can also set up an oval object. Let's say oval 1 and say draw. This is going to work. If we say oval 1, draw and pass in a parameter, let's put in 54, for example, this is going to do. You're going to see that this is going to be accepted by Visual Studio Code. And if we build and run this program, it is going to be calling the inherited functions in oval and circle here. The build is good. We can kill our terminal here and bring up a PowerShell window we can use to run our program. We're going to see that we call shape draw and shape draw because these are inherited functions from the shape class. That's why we are saying shape draw here. And we're going to be drawing our oval and drawing with a color depth. We're going to be drawing the circle and drawing with a color depth here. This is the message I want to convey. But the moment we override these methods in any downstream class, for example, if we go in our oval class and comment out the override for the draw method, notice that we are just overriding a single overload. Again, if we go back to our shape class, we have an overload that doesn't take any parameter. We also have an overload which is going to take one parameter. In oval, we are just going to override the overload that doesn't take any parameter. But this is going to hide all the other overloads we had for the draw method here. And this is the only overload that is going to be available in downstream classes. So if we go back in main, we're going to see that the one with a parameter is not going to work, and we're going to get a bunch of compiler errors. This is going to be the case even in circle. If we uncomment this guy, the others are going to be eclipsed Again, the other one we have is just the one with one parameter, but this is going to stay true even if you have 100 overloads. All the others are not going to be available if you happen to only override one of the overloads. In other words, the other overloads are going to be hidden by this one override that you are putting in your inheritance hierarchy. You should really know this. If you want this guy to be available in downstream classes, for example, you can also override that in derived classes. This is an option. We can go in oval and put in another overload for this. This is going to bring this back in scope. So we can say oval draw here with the color depth. I don't think we copied the right thing. We can grab this and go in oval and put this in place. This is going to do. We're going to say oval drawing, and we can go in circle and also put this in. This is an option, and we're going to say circle drawing. And now you see that the squiggly lines in main go away because we have overridden all the overloads. Okay, if we build and run our program, we're going to see that this is going to work as we expect. The build is going to be good, and we can clear and run Rooster. We're going to see that overdraw called. We are calling our derived overrides, and this is really cool. This is what we want here. Let's take this back because we don't want these overridden in our inherited classes. So we're going to take this out in oval, and we're going to take this out in circle. And I want you to see that shape polymorphism is not going to work if you override your methods at a downstream level. So what we are going to do, we are going to go at the oval level and set up another overload for the draw method here. But this draw method is not going to participate in shape polymorphism because it is really declared at the oval level, and any base pointer we have or any shape pointer we have is not going to have any knowledge of this overload that we are about to set up here. This is what I want you to know. Okay, so we are going to go in our oval class and set up that overload. We can set that up here. It is going to be taking two parameters. One is going to be the color depth. The other is going to be the color. And we don't want to pass a string by a value like this. We can use std string view, and we can include that if we need to. But it looks like Visual Studio Code has got this from something else we have included before, but we can include that explicitly to avoid problems. So let's do that. We're going to say string view here. And now we want to see that this method is not going to participate in shape polymorphism, even if it is a virtual functions. The reason is, this is not going to be known by your shape pointers because it is not declared at the shape level here. I really want you to know this. We're going to take out everything we had here, and we can set up a shape pointer. We're going to say shape and say shape ptr, and we're going to set up a derived object here. We can say new and say circle. And what do we need to build a circle object? We need the radius and the description. So we're going to put that in place here. The radius is going to be something like 10. Why not? And the description is going to be circle 1. How creative. And we want to see if our method is available through polymorphism. And it is not going to be available because the method was not declared at the shape level. So if we do shape ptr and say draw, and we have a method which is going to take two parameters at the oval level. We have the color depth and the color. So for example, if we go in main and say the color depth is 45.2, why not? Let's say this is something that makes sense, or let's use 45 because this is an integer parameter, and we're going to pass in a string. Let's say red. You're going to see that this is not going to compile because the draw method with two parameters is not known at the shape level. This is the message I want to convey here. So if you want your method to be usable with polymorphism, the method has to show up at the top level. This is what I want you to see here. If we're trying to build this, we're going to get a compiler error, and you need to be aware of this. But note that even if this is not working with shape polymorphism, this can work with oval polymorphism. And this is an idea I am going to explore in the next lecture, where we learn about the fact that polymorphism can be set up at different levels. So we are going to stop here in this lecture and explore that idea in detail in the next lecture. So go ahead and finish up here and meet me there.